Okay, welcome back to the help sessions. So to start off with, anyone that is new, on the YouTube, there is a chat. Please use it, please respond. So after I say something, please say yes, no, I don't know, whatever. It's just to keep the communication up, and it's just a common courtesy. I would do the same back to you if you needed help. So please just do that. It makes it easier for me. All right. If you're here, and I know who is here through LMS. So if you have a question, I wouldn't ignore you. All right. So use the chat and just say yes, no, etc. First things first, though, can you all hear me? Can you hear me? Maybe not. Yep, cool. All right, so the first thing we have is a question about the assignment. So do we need to use all the complex number functions? So there was a bit of a curveball there, because no, you don't need to use all of them. So there is 4 functions. There's 4 complex number functions, and we want to see all of them. But yes, you only need to use 3. So with that, I'm not going to tell you which 3, but you do have to use at least 3, and you do have to use them wherever you're using complex arithmetic, because we want to see certain things, and it is in the rubric. And I have answered this question already in the forums if you've been following the forums. Okay, so there are 4, and you have to use 3. Does that answer that question? But keep the one that you don't use in there still, because we want to see it. And you'll notice that it doesn't affect the code. So if later we wanted to do something else, we could always use it. It doesn't hurt us having it there. It'll actually make it better for later operations. Yep. Okay, the second question, I might have to get some context. Have you uploaded your code recently? So there's another question about a binary operation between 2 things. So actually, I probably don't need to look at code. So I'll just do an example. I don't know the exact circumstances for this one, but a binary operation is pretty much any operation between 2 things. So a plus is a binary operation, a minus is an operation, a binary operation, times is a binary operation, a mod is a binary operation, a equals is a binary operation, a greater than is a binary operation. So we do have, so these are all binary operations because they're between 2 things. We also have unary operations, so things like plus plus and minus minus. They only affect 1 thing. And we do have a special case where we have a ternary operator as well. Okay, so let's have a look at binary operations. So the question is that there's an error saying invalid operands. Now, just one other thing I will mention, and you'll find out about this a bit later as well, but in the exam, you will need to understand error messages, okay? And that shows that you understand the theory, because you should be able to read this and work this out. So let's break this apart. So invalid operands, so operands being the things being operated on. Is that the right error message? Can you just check the error message, make sure that's all of it? It seems a little odd. You're missing something there. So there should actually be a symbol there, which I'm going to assume is, let's say, a multiplication. So double check your error, firstly, because you're missing a bit of information. It could be anything here, but invalid operands to binary multiplication have double and double star. So we have a multiplication, so binary star means multiplication. If I had binary plus, it's a plus. If I had binary greater than, it'd be a greater than, and so on. So we have a times, and if we want to times two things, then these need to be standard variables. Okay? So basically it's saying one of your variables is a double and the other is a double star. Okay? So it's basically saying this one's okay, but this one's a pointer. So what are you trying to do? That doesn't make sense. Okay? As you saw earlier, we can't multiply a pointer. So basically, a simple example of this would be int star p. Actually, I'll do int star p, int w, and then we've got, let's say, p becomes the address of w, and then I do int x equals p times w, and that would give that error there. Okay. Another thing that would give that error, well, except for it'd say int and int star, sorry, would be if you had p brackets, let's say 1, 2, 3, because p is an int star, as we learned a couple of weeks ago. So that would also give an error, similar, except for it'd say int star. Crazy. All right, so does that explain that error? Okay. Sure. So, where are we? That is a really excellent question. So let me just move across. So that's actually a really good question, and it is kind of difficult to explain. So, so we're dealing with doubles. Using literals. Okay, so a 1 is a literal, a 1.1 is a literal, as we saw earlier. Okay, this is a literal character. This is a literal string, and so on. So with our float, actually, let me get the standard up because this will help me explaining this, because it is a standard. Okay, so I'll just copy the standard. Right. So let me copy and paste that. Right. Like it's with double precision as well. Sorry about this. Just getting this stuff for you. Okay, so this is actually quite a difficult problem, and there's a whole field of analysis for this. But with floating point numbers and doubles, God, sorry, my computer's being stupid. All right. Right, so this is a float, and this is a double, and this is how it's stored in memory. Now, the fractional part looks something like this, and you can see that the fractional part for the double is quite a lot longer. Now, what this means for the fraction is that not every single fraction can be stored perfectly. And this last digit is truly not accurate. And so you can end up with accuracy issues. Now, when converting from a 0 to a double 0, you may introduce a tiny inaccuracy, and this may end up as a 1. And so what you end up with is 0.000, lots of zeros, and then a 1. So to overcome this, basically what we do is declare a literal to be a double. Okay. And that's basically why there's the L there. Because there's a couple of conversions going on, because you're going from an int down to a float and so on. So, where am I? So you need that L there. So let me grab up the list. I'll grab up the list for you. So, yeah, I can't find it. So we got one question. Does that stand for long? So no, it doesn't stand for long. Lowercase l is long. So that'd be 0 as a long. So we can use different things in our literal to make it mean different things. So for example, 0 in hex would be that. 0 in binary would be that. So that's hex, binary. 0 unsigned. 0 long. 0 unsigned long. 0 as a float, and 0 as a double. Okay, so this just helps us with reducing errors with precision. It may not make too much sense now, but if you remove this L, you may notice that your answers will be for your voltage part will have this tiny, tiny, tiny number added to them. Okay, and that's why we use the L. So this is long, double, sorry. And the lowercase is long. All right. Further than that, you don't need to understand too much. It is quite a big field of study. So I'm not expecting you to go too far with that. Yeah. All right. Is there any other questions about the assignment? Or should we continue? So I'll just give you a minute if there's any other questions. I think most people have nearly finished, so there's heaps of submissions already, which is great to see. Most of them seem pretty updated. So, did you watch the video from the semester break video? Because I've already gone over the total impedance part. Right, so that's the break video, and it's been about an hour or more on that, because that part's probably the hardest bit of the whole assignment. The rest is not too bad. Any other questions? No? Alright, so we did structs last time. So hopefully that was helpful. Next week's lab is all about structs. And if you understood the example from the last session, it will help a lot. The lab isn't too long, but if you don't understand structs, it gets very confusing. So I've uploaded the code that we did last time as well, so you can play with it, change it, do whatever you like with it. It's next to the video from last week. But I thought we might look at strings. Unless there's some other thing that you want to know about structs. Sound good? Say yes if that sounds good, or if you've got anything else. So fourth person. Good, good. All right. So you won't see strings much in the labs, and that's purely because I don't see much use in them for a lot of the stuff that you're going to be doing, and I do not use strings in a lot of stuff that I do, so they're not used very often in the labs. I think we'll use string functions like once. You'll use string literals a lot, but actual strings, not so much, because we're not really going to do, like, if you're doing IT or engineering, it's unlikely you're going to be doing word processing in a lot of cases. It can be handy, but once you understand the basics, there's not too much you can do with it. So oops, you won't see much on strings in the labs, but you do need to know it for the exam. So we'll go through some stuff on strings, but as I said, yeah, I don't really like them. So first things first, let's go string A. Is that legal? In C. Is there a reason it's not uploaded? I uploaded it today. Oh shit. Wait. That's what. Ah. Okay. I'll fix that up after this. If I forget, to send me an email. I haven't set up the submissions. That's odd. I'm sure I uploaded. Damn it, I must have stuffed something up. I might have uploaded it to a different subject. Anyways, all right. So let's have a look here. This is really, really wrong. So there's no string type in C. Okay? We can use strings, but strings are a concept. And we more look at the literal side of strings to explain strings. So a string is purely just an array of characters. So we've seen string literals quite often. So we have a string there, and that's made up of characters. So quick question, how many characters are here in this string? So I know you're listening, please answer. How many characters does this have? Is it 1? Okay. So it is really important to understand that this is 6 characters. So as a literal, it will always default down to having just one null terminator. Okay. Now, you may have seen the null terminator like this. However, it is not null. Okay. So let me just get something up for you. It is not null because these are characters. Remember, only a pointer can point to null. So you will notice that it's actually, so if we've got the ASCII table, you'll notice that its character is null, but its actual value is 0. So if you print this out as a decimal number, you'll get 0. So the same as if you print out C, the character C, as a decimal, you get 67. So let's actually try that. So actually, I'll come back to that. Yeah, let's actually try that. So we've seen earlier that we can declare an array, something like this, 1, 2, 3. And this will automatically put 3 there, okay? So we don't need to fill that out if we're only the first time we're initializing. And you have to initialize if you want to leave this blank, or else it doesn't know how big you want it. So we can do the same with characters, and we're going to do the word hello. So I'm going to go car A equals hello. Is that correct? Or have I done something wrong? So I've done something wrong here. So a string is a character array. Now, this will give us an array of size 6. Okay? So what I'm... No. So this is quite important. So if you put it in curly braces, then you're trying to say an array of strings. So if I wanted it in curly braces, I could do this, however. Purely because these are every single element. However, this is an array. So putting a curly braces would indicate that this is an element of the array. So if we had an array of strings, then yes, we would need curly braces. But we don't have an array of strings. Okay? And so you can, if you wanted to, declare your array like that. However, it'll probably drive you nuts. Now, what we can do is create a for loop. I'm just going to get rid of this A so we don't have two things defined. So I'm going to have a for loop for I equals 0, I less than 6, I plus plus. What I'm going to do is do a printf %d. And I'm going to do a I. Okay. So I might actually put like a comma or something in there as well. So given that, and can we grab the ASCII table? It's still on the same layer. It is. So I'll just move that down to somewhere around here. And still have enough room. So I'll just make it smaller. So my question is, what would be printed? In this case, I'll give you a couple of minutes. Okay, so let's have a look. So the first character is a H, so we get 72. Then we have E, which is 101. Then we have L, which should be 108. We have 108 again. And then we have O, which is 111. And we need the sixth, and we get 0. Okay, and we can see that it's a 0. All right, don't forget that there is that null terminator. So now what I'm going to do is change this a bit. And I'm going to make this 8. And I'm going to make this 8. So what gets printed now? Is it going to be 2 garbage values, or is it going to be 2 null characters? So the answer is that it's 2 null characters. So if you initialize your character array like this, or string, then you actually end up with this HELLO terminator, terminator. How many we got? 6, 7, 8. Okay, you end up with this. All right, and that can actually be quite helpful. So we also have something else we can use with our strings. Now, one thing that you should kind of avoid, because there's a kind of better way to go about it. So cast star A equals hello. A1 becomes B. Printf. So we can do a %s, which means string, and we just need to pass the address of the starting memory, which we know A is a pointer to the starting memory address. So that's perfectly fine. So what would be printed in this case? So the answer is it won't print anything because it will crash. Okay, so this is something that you have to be very careful about. And this is something that's a little strange about C and has to do with very old versions of C. And it's still in C because of that. Now, basically, if you declare your string with a pointer, this is stored as read-only. However, you get absolutely no warnings about using it, which is why it's bad. So, whenever using this, you should always, if you want read-only, you should always go car const star a becomes hello. Now, this won't allow you to do any more, okay? But what will it do? So if I change this to const, oh, sorry, if I change this to car const star a, what will it do? If you don't know, just say don't know. But we have covered const before. Okay, so this is a pointer to a constant character. Okay, meaning that this is read-only. Okay, so it's doing exactly the same thing. However, it will do one better because it will give me an error on this line. Okay, so it won't crash, it'll give me an error because it'll actually give me some information. So car star a and then some initialization versus car const star a and then some initialization. They both do the same thing. However, this one will actually give us an error if we try and use it inappropriately. So you should always use this and not this, unless you're going back in time and you need to use this for very, very old stuff. This is a lot safer because as soon as you try and use this, if you do it this way, your program crashes. All right? Where this will give you an error saying you're using it incorrectly. It means your program won't compile, but it won't crash. We would always prefer an error over it crashing. Does that make sense? It is a little confusing, but that's only with strings when you initialize it with a pointer. And for some reason, that's legal. But even the syntax is kind of weird because it goes against some other rules. All right, so you shouldn't even need to do this in this subject, but if you do, add that const there, because then it says that this is read-only. This is read-only, but it doesn't say it is. All right. So let's go back a step. So let's get rid of all this crap. And what I'm going to do, I'm pretty sure it's already written this before quicker. So I'm going to change this, get rid of this error. I'm going to change this to, I don't remember what I called it, A, I think. A. All right, now what does it print? Once again, No, not an error. So if you declare it this way, this is just declaring an array. Okay, so it's not just read-only memory. So it will print HBLLO because we changed the B. So A0 is this one, A1 is this one, A2 is this one, and so on, as we saw with the printing example. Okay, so I'll just print HBLLO. All right. So as long as we create our array using this, then it's not read-only. So my next question would be this. Yeah, I can do that. Oh, sorry, I forgot one more thing. Let's see. Okay. What would this print then? Yes. So HCLLO. So you can point a pointer to this array, but it's only when you initialize. If you use a pointer there, then you get read-only. But this isn't read-only, so you can change it. Okay? So this here looks like a normal array. A car, A 1, 2, 3, 4, 5, 6. And it would have the character H, the character E, the character L, character L, character O, and then the null terminator. Okay? So remember, this is all stored in binary. Okay? And then if we have B, it's just another pointer. So it takes the value of this, which is pointing to the first spot. And so this is also pointing to the first, and then car B1 would be B plus 1, and then dereferenced, so that becomes C. All right. In the example before where you had the star here, basically this is a little bit difficult to explain, but you have a car star that points at just hello, a new character, and whatever's in that block cannot be changed. Okay? You can read it, but it can't be changed. You can point to it, but another pointer can't change it either. Nothing can change it. All right? Because it's read only. But as I said, you probably won't need to ever do that. Okay. Okay. So that's only when you've got that there and the initialization. You can still use malloc and do something like car star A becomes malloc 6 times size of car, and you'll get an array you can play with and change. All right. However, one thing you cannot do this. Car A 6 and then go A becomes, oops, why did I do that? Hello. So this is also illegal. Okay. It is for the same reason that you can't do this. Let's change the type. Okay, so both of these things you can't do, all right? Because once they leave that line, they're just a pointer. All right? So don't try and do either of these. You can initialize it on that first line when you declare it, but other than that, you cannot change it like that. All right? Does that make sense? So going back to this example, I'll take a couple of minutes break. What I'm going to do is change this. I'm going to write address of the one here. So I'll be right back, and I want the answer. Okay. Okay. All right, so yes, we have CLLO. Because remember that string wants the address of something, so it's just getting the address of the second element. All right. So what else can we do with strings? Think if there's any other good examples before we get on to string functions. So that's all good, that's all good. All right, let's go up here then. So you saw in the last week's stream that if I want to store a certain amount of characters, and I don't know what's going in there to start with, and I don't want to dynamically allocate it, I just want to give enough space, we can just put a number here. Okay. However, with any constant, you should try and define a macro. I won't call it that, I'll call it, oops, no, oh, sorry, everything just went. Okay, so we just put the length there. Now, what's the longest string in terms of none command characters is going to be 79, because we still need that command character for the null terminator. Okay, so just be aware of that. All right. So that's pretty good, that's pretty good, that's pretty good. And if we want to make a string using characters, we can. So if we go car A4, we can go A0 is H, A1. Oops. What was that? Is high, and then I can do printf %s, and I can print out A. Now there's something wrong here. So can you tell me what's wrong? And then I'll go on to the other question that's there. Okay, so if you don't know, so I'll answer this first and then we'll get onto that. What is wrong here? So the problem here is pretty much that we don't have a null terminating character. And so what we'll see when we try and print it is it will print a bunch of letters, and it will either segfault or reach some random place in memory that has a 0 in it, an end. Okay? So if I put a null terminating character here, this will work perfectly fine and print high. Okay? But if I don't put this here, actually it's a good example, so I'm going to actually make it because it's very quick. So let's write this out. And yeah, it'll do either of one thing. So it'll either segfault or just find a 0 in memory and end. So into this. So this is the version without this. Oops. And this one was quite good. It reached a 0 quite quickly, but it printed this other character in memory. So let's try again with something, well, something a little longer. Let's get 14. Let's do hello. So let's move. So I'll give you the code in a second. And then we'll go on to that exam question as well. Not exam, the assignment question that's on the basically. So I'll just screen that so you can see what I'm doing. So I'm just doing this at the moment. Okay, we'll run that one. And it actually found an null terminating character here. So this is just being lucky. This is why you have to be careful with C. There is a lot of zeros in memory, but if you don't come across one, then you just keep going on. It may segfault or do something weird. So here's another example. So I added a exclamation mark, and you see it has just some random characters. All right. The reason it doesn't segfault and keep going forever is because there is a lot of zeros in memory, especially free memory, just due to functions and programs just trying to clear their memory. But yeah, we do need a null terminator at the end. But that's perfectly fine because we're looking at characters. However, what we can't do is put double quotes here, okay? Because it's a character array. We can only use the double quotes when we're talking about a literal. Okay, so we can have car a blah blah, but we can't have A0 becomes a whole string, as we saw before. All right, so now I'm going back to the exam question, the assignment questions. So the question was, if we have a void function, basically that means that there is no return value. So we can't have return something in our function. Okay. So we can, however, have return, but we can't have return something in our function. Because it's void, So we're returning by reference using pointers instead in our functions. Does that make sense? So this will give an error. Now, the expected declaration or statement at end of input is a difficult one, and it usually means you're missing some braces somewhere. And the line number won't help you very much because it could be kind of anywhere. So the person asking the question, how do we return by pointers? That's what we've done in the last probably 3 or 4 weeks in this subject. And it's something that probably 50% of the exam is going to be on. So if you don't know that by now, that's not very good. So remember that we can pass an address to a function and we can dereference it. So if we have int, my function is called w, and I have int star a, then by dereferencing a, I can pass a value back. If in some other function, so p, let's say it has int x, and I have w, address of x, then that would pass the value back by reference. Okay, so x would have 4 in it after this operation. Now this is something that you really need to know how to do, because it's basically what we've been doing for most of this subject the last 3 weeks. Yeah, I was going to say, you scared me. Cool. All right, cool. So we've looked at printing strings. Now, we can do some more things with strings, which are kind of weird, and I don't think I've ever used this, but it's kind of funny. So if I have a string, let's say A, and it's hi. Actually, I'll make it hello. So there is, in the format specifier for a string, there is actually precision, which is kind of weird in itself. So I can go .3s, and you're probably thinking, how can this have 3 decimal places? Well, it doesn't. But what it'll print 3 characters. So we'll get HEL in this case. I don't know how that and where that would be useful, but it is kind of funny. Now, one other thing you can do, which is weird, I don't know how helpful, and I don't think I've ever done it really. So let's say I make a for loop. So I less than 8, I plus plus. And I'm going to go printf %C. And then over here, I'm going to put a string. And I'll put Matthew. And I'll put I there. So this looks really odd. But remember, this is an array. So we can use subscripting on it. So this will just print Matthew. The last one will be the null terminator, which will print as a character, but you won't see anything on the screen. And it doesn't make a difference to the screen if you use it or not. It's actually more to help if you use %s, or you're doing a string function. For printing, it doesn't actually do anything very useful to the actual screen. So I could actually change this to 7 and do the exact same thing. But yeah, that's a thing and it works. So you could also, if you were so inclined, you could do something like int input scanf %d address of input. So you could have a string and you could ask the user which character they want to use, or to specify a certain character. Once again, I don't know how useful this would be, but I just thought I'd show you because it's kind of weird. And that will grab the inputs character. Okay. Which, yeah, I don't know how useful that would be, but that's a thing. All right, who's still here? If you're still here, let me know. Cool. All right. So just having a look. Ah, lost it. All right, cool. All right, so we've got the basics of strings down, which is good. But now, actually, what I want to do is something different. So I'm going to do car, a, for, actually I don't really keep it up how long it is. I'll put a literal there anyway. So I'm going to put hello. Then I put car B hello. And then I'm going to put if A equals B. If A equals A, so my question is, what would be printed here? If you don't know, just say don't know. Once again. So we have to think about this and have a look at what's happening here. So I'm going to use a box and pointer diagram because I think it will explain what is happening here a bit better. What the hell am I doing? Oops. 6. Okay. So I'm going to do something a little different here with my box and pointer diagrams. Nothing too strange, but I've got my little pointers to the first memory address, as you know. Type car. And I've got H, E, L, L, O. I'm just going to put a 0 there because it is a 0. H, E, L, L, O. And let's say this has memory address 4. This has memory address 62. Okay. So the value of A is going to be address 4. And the value of B is going to be address 62 in this case. Sorry. So A is not equal to B, because the value of A is address 4, and the value of B is address 62. So this is false. However, 4 and 4, address 4 and 4 is true, so let's say howdy. Okay, so remember with arrays that if I specify the name, I'm talking about the pointer to the first element. And that is holding an address. And both A and B are different arrays, so they're going to be pointing at different address spots in memory. Okay, does that make sense? If it doesn't, just say it doesn't. If you don't like it, just say I don't like it. Alright, so this is quite important and where a lot of people make mistakes with strings and even arrays in general. Because this example could be arrays as well, so we could go, and remember a string is just a character array. Well, we can still use car, it's fine. But if I did 1, 2, 3, and I had 1, 2, 3 here, exactly the same problem. Okay? All right. So we need something to help us do stuff with strings. Okay? So we need a new library. Hash include string.h. Okay? So this is a new library that you're probably going to include sometimes if you want to do string stuff. So let's have a look at string compare. So if you want to compare a string, we use string compare. Oops. So what I might do is I might actually create a new page. So I can get busy here. I might start keeping a list of functions we go through. So we're going to have string.h. And the first one we're going to look at is string compare. All right. So this is a nice function, and it will compare two strings. So now I'm going to do my example again, and I'll have car. A is hello, and car B is also hello. Now, what I'm going to do here is I'm going to write if string compare A and B equals 0, then we say hi. Well, we needed a printf, but you can get the point. Printf hi. So this will actually work. And this will compare the two strings in terms of the whole string. Okay? So string compare returns different values. So if they are equal, so if equal, it returns a 0. Now, if A is less than B, then it returns a number less than 0. And if A is greater than B, then the number is greater than 0. Now you're probably asking, what do you mean greater or less than? They're strings. What's their numerical value? So how string compare works, it uses lexicographical ordering. I hope I spelled that right. And basically that's dictionary ordering. Okay. So if it's a character less than, so obviously apple would be less than beach. Okay. So if we had apple and beach, then string compare would return a number smaller than 0. Now you'll notice here also that I didn't store the result of string compare, so I could have done something like int w string compare ab and then use w here. But really, I don't care about storing this value if I just want to check if they're equal. So I just return the value and compare it with 0 straight away. If you wanted to use this number, and this number, if you know what this means, so you're basically looking at the how different a number is by looking at that number, then maybe you want to store it, but really, or if you want to check if it's greater than, less than, or equal, then you need to obviously store it so you can do an if, else if. But that's string compare. Now there is also a variation on string compare, and you'll notice that with pretty much all the string functions, you'll have an n version. So the other version is string n compare, and basically it will have a third argument which will specify the number of characters to compare. So let's go back to another example and go hello and hello. These will be equal in this case because we're only looking at the first 3 characters. Okay, and they are equal, so it'd give me a 0. Does that make sense so far? So there's 2 versions. This one has 2 arguments, which is a caster and a caster. And this one has 3 arguments, which will be caster, caster, and then an int. Okay? And they both return an int, which is this number. Say yes if it makes sense, no if it doesn't. Hurry up, slow down, this is stupid, whatever you want, just write stuff, it makes it easier. Tell a joke. All right, so that's comparing. So we can't use the equals operator, we need to use string compare. Now, what you might find interesting about this as well, what if I might give you a question. So I've got a character array. Remember, characters can hold numbers up to 255, yeah? I'll answer that question in a second. Actually, I think it's at the start of last stream. I've answered that question already. But but I will come back to it. So I'm going to put numbers in instead. And I'll put 88, 104, 108, 88, 104, 108. I hope I haven't spelled something bad. All right, so here I'm going to do my string compare with A and B, and this will still work because it's still a character array and it will actually return 0 because they're the same. Okay, we've just specified it as a number when we've initialized it. It doesn't make a difference. Remember, it's all stored in binary. Okay, so someone's come in and asked a question about segmentation faults. So I'm going to refer you to a couple of things. Let me just get it up. So on LMS, there's, oh, let's go to the assignment one. There's a segmentation fault debugging tool, so you can use that. The other thing that could help is if you go to the last live stream, right at the start, someone asked the same question. Okay, so if you go to Wednesday's one, you can get that information. And that's right at the start because someone asked that question at the start. Okay? So does that help? Hopefully they got that. All right. Now, a really handy function in the string library, and this is quite helpful, and this is string len, which stands for string length. So if I have car A hello, and then I go printf %d string len A. So what would this print? It's all the people's. So the answer is actually 5. Okay, string length doesn't include the null terminating character. So it's something you should be aware of, because if you're trying to do a copy or something, that can kind of work against you sometimes. But it can also be very helpful because if you have a string that's, well, let's go like this, as we saw before, that has HELLO and then a bunch of null terminating characters, which is quite often the case with strings, then it will tell you the actual length of the string in terms of its characters. And this is why this is very helpful. So you would have seen last week that I made a string of 255 because I didn't know what the user was going to enter for the name. So I just gave enough space so that it could handle most cases. Okay. So the reason I put 255 there is because I still can get its length. All right. So size of here won't work because we won't know how long it is because we'll have a bunch of zeros. All right. So that's why string length can actually be very helpful. All right. So what other functions are there? So we've done compare, we've done copy, I guess. This string, yeah. Okay, so another very, very helpful function is string copy. Now there is another function which I don't think is in the lectures, but is quite a handy function, which is m.copy. Have a look at it if you've got some free time. You won't need it in this subject, but it is very handy. So string copy allows you to copy strings. Now, this requires some consideration in terms of size. So I'm going to make a character, array, string, of size 10, and I'll make it equal to hello. As I said, I don't use strings very often. Copy 10. So with this, we can use string copy, and we can do this. B, A. Now, basically, this is the source, and this is the destination. Okay. Now, what is kind of good about this is that we can also do this. Okay, so we can actually copy a literal straight in, and different things like that. So if you want to copy a string, that's how you copy a string. You've also, so the prototype is going to be car, star, and car. And you've also got an N version of that, which will have a third argument, which will indicate how many characters to copy. It will always put a null terminating character after that as well. Now, you need to be careful with this also. If you try and put something smaller here, so let's say I put size 1 here, it will try and copy it, and the behavior is actually undefined. So that's dangerous. All right, and that's how you copy. So, the devil. Okay. This one's safe paste. What's the condition? What condition? No, they don't have to be the same. It's just that it can't be smaller. So it needs space to store it. So if this is 3 in this case, that's fine because it can store high. Because it's just as long as this isn't, so destination has to be greater or equal to source. Okay. Okay. Okay, so sorry, I got distracted. So the next thing is getting a string from the user. And this has a big problem. Now, there are some solutions and discussion in solving some of these problems, but the best way to go about it is by limiting your buffer. So what I'm saying here, if you use scanf and you go %s, and okay, let's say I've got car A 30, okay, and I go printf, enter your name. Now, that's pretty good, but the problem here is that the user can enter a string of any size. Okay. So we have to be very careful here. So with this, sorry, I'm just check something. With this, we can limit the number of characters by putting a number there. However, the problem with this is we end up, we end up having to limit the size that the user can enter. So there is ways around this, but what's a good idea is to try and limit it. So use %30s and that will limit you to 30 characters. However, we should actually limit it to 29. Okay, so that we can store the result. Yeah, so I'm just going to take a quick break. I need to check something. Sorry. And I'll be right back. I should leave you with something. I have to make things leave you with. I'll be right back. All right, sorry about that. I'm back. All right, so I might actually start again because I was kind of distracted reading stuff. So let's go back to what I was saying. So I want to get something from the user, okay? So I want to get some word. So I'm not muted now. Cool. So I create a variable 25 and I use scanf to try and get it from the user. Okay. %s and a. Now this will work, but it is unsafe. Okay, because I can actually overflow the buffer. All right, so I can overflow this A, and this is really, really dangerous. And actually, there was like a worm that was actually used this to exploit certain things by accessing bits of memory by using very dangerous code like this. However, what we can do is put a number before this, 24s. However, this isn't unsafe, but it may be unsuitable. So, actually, I might make it a smaller number, so I don't have to write as much. So I'm going to make it 10, 9. So if I enter onto the screen, hello, and then press the enter key, that's fine. In A, we'll store hello, and then the null terminator, okay? Which is all good. But if I send hello, hello, then it's going to get the first 9 characters, 5, 6, 7, 8, 9, and it's going to store that into A. However, if I didn't have this, then it's going to try and store all of this, which is dangerous because I could keep writing, and this only has 10 spots. However, the problem here is that, let's say I did printf, what is your name? And I had 9 here. And then I did printf, what is your age? Just scanf %d, address of B. So if I had my name as hello, hello, then it would store this, but this O would still be on the buffer. And this could be quite long as well. I could have written a whole huge line of text. What I could have also done is a bunch of other stuff here. Okay, so this O is still there, and there's also a new line somewhere down the line. So this isn't very good, this scanf. Okay, so you need to be aware of that. Now, there is ways around this. All right. So the first thing that you might see, I'm going to do this in red. put a little skull and crossbone here. Fire. Okay. So if you use this, you'll actually get. I'm actually trying to do it because it's oops, kind of funny. One second. Why is that gone? Where are we? So there is a function called gets, okay? And if you compile with gets, just give me a second. The actual message. So if you use this, and how it works is you write gets, and then you put, so let's say I've got car A 10, and then I put A here. And this will get a string. All right. When you try and use this, you'll get a warning. And the warning is, warning, the gets function is dangerous and should not be used. Okay? So even the compiler says, why the hell are you using this? All right? So if you use this, I'm going to be very angry. Okay? Do not use the gets function. The problem with gets, you can't limit the size of the buffer. And so there's no way to limit this to 10. Even though this still has problems, this is a lot worse. Okay? Both of these have problems, but this one is a lot worse. Okay? So be aware of that. Now, there are ways to get around this. And this is by using fgets or ss or scanf. So So if you're reading a string, you can get around this by trying to find the new line character and try and get rid of this. You can also use fgets, which I'm not going to introduce right now. We'll look at it when we get to files, but this can help in this problem as well. Okay. So for now, do it this way and check if there's a new line if you want to validate and keep going. Because obviously it'll crash otherwise. And you should know how to check for a new line. You can use a while loop or something like that to basically find what's going on there. The fgets is actually the best way to go about it, but we'll look at that when we get to files. So I might just leave that for now. Okay, because fgets is the safest way to go about it. This is still unsafe in some regards, but gets just stay away from. Okay. The reason it exists is basically for backwards compatibility with a very old code, and it is from a long time ago when it was originally created. But now you know that, so stay away from that. You'll learn how to do it the proper way when we look at files. And if you're interested, I can show you what gets can do. Basically, I'll find it later and I'll send it. But there was a worm that was created using it many years ago, and it caused a huge amount of problems. All right. So let me have a look what else I've got here. Strings. Yeah, it's pretty much for strings. But yeah, we'll look at fgets when we get to files, because the truth is that your input is actually a file, which is a little bit confusing, but it is. And that's why it's the safest way to handle it using fgets. So that's strings. Have we got any questions? So far. Nope. Okay. No questions. Q. All right, so what we might look at, just the start of a new topic. So we've seen main before. Okay. And we've also seen some programs on Unix. Okay. So main is our entry point to the function. Okay. I mean, entry point to the program. However, we notice with CC, the GCC compiler, oops, we can write a bunch of stuff after the program's name. Okay, so we've got the program, but we've got a bunch of stuff after the program's name. Okay, and these are called arguments. Okay, and so far with your programs, you've just been writing the name, but you have no arguments. And even if you wrote arguments, you don't know how to get your arguments. Where did these go? Okay. So your programs can have arguments too. So you could have a program that maybe shows all the warnings. Or maybe you write a compiler. Don't think you'll be doing that in this subject. So we can have arguments too, but we have to do some things to get arguments. So just as one thing you should be realized. So arguments are separated by a space. Okay, and that's why they're defined. So if on the very first lab there was people that wrote wall -o, things like that, it wouldn't work because they're separate arguments. So let's have a look at main. So I think main is int main. Now, what about this part? Am I crazy? Okay, so you'll notice that my int main doesn't look normal anymore. It looks a little different. This is legal, okay? And we're allowed to do this. And this allows values to be passed to the program, okay? So this allows us to do a lot more, because now we can pass values in from the command line. All right. So we get two things from the command line. So these have to be spelled exactly like it is here. You can't change that. And it has to be an int and it has to be a cast data array. So let's look at this first one first. So this one tells me how many arguments. So let's just do a quick question. We'll go back here. Now, I kind of lied to you a bit, but how many arguments would my thing print here? None and no brackets. All right, so it's 3. Because we have 3 arguments here. I don't know why. So our program name will actually be an argument as well in the count. So your arguments are always going to be greater than 1. Okay. However, someone said no brackets. This isn't C anymore. Okay. This is an executable on the Unix machine. So there are no brackets, as we saw with CC. There's no brackets after the CC. So our program has 3 arguments. Okay. The name, and then our actual command arguments. Okay, which is 2 and 4 in this case. Okay, I might actually change it to hi. It's a more interesting example. Okay. Does that make sense? So you can start writing a simple program and just go printf empty argc. Okay, and this should just tell you how many things come after this. All right, so if you created a program and you just printed how many things, and that would test and show you how that works. And I recommend you do that. Okay. And argc, just so you know, stands for argument count. All right. If I can spell. All right. Does that make sense so far? Yep. Cool. 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 The other one is the argument vector. So this is, as you can see, the star. It's an array of strings. Okay. So you'll notice that it's car star. So this 2 is going to be the string 2. This high is going to be the string high. All right. Oh. Now, what we can do is also check these out. So I could do a for loop. So it's I for I equals 0, I less than argc, I plus plus, and I could do printf CentS argv I, and that should print out all the strings arguments for me. Does that make sense? So let's have a look at this. I'll show you. So this argv would be a pointer. So in this case, there would be 3 pointers. One would point to a string happy. Another would point to a string 2. And another would point to a string high. Okay. And none of these have names as well, except for this one, which is argv. The length of argv is always argc. Okay. So in this case, this print would print happy to high. So we'll just repeat the line we've just written. And yeah, I recommend you try that out because it's a good little practice program. Often this is really handy with files. So in your program, we don't want to talk to the user anymore, but rather we want to talk to a file, which is often the case. So for example, let's say and we'll go through this in more detail on a later date, but let's say I wanted to make a program called simulate X, and then I can put input 1.txt, right? And so it means that rather than having the user enter a whole heap of data, they just input the text file at the time they call the executable. You could also ask the user, please enter an input file, but this can be quite helpful with scripts and stuff like that. Okay. So have a try of that little program and see what you get, see how you go. You might want to put a space after this. But yeah. And we will see this in one of the labs coming up, I'm pretty sure. Okay, we've got a question. If we want to pass an address of a pointer from which we do not want. The question makes no sense whatsoever. If we want to pass, so you want the address of the pointer, so in star A, and you want the address of A, so let's work out what we're going on about. So we've got A, and you want to pass the address of a pointer. So let's go in. Just go. Let's make this int P. This is our function. And we've got int W, which is another function. And we want to pass an address of a pointer, meaning we need a short star star. We'll call this X. Okay. Which we do not want value to be returned. Okay, so we don't want a value to be returned. I'm assuming you mean from the function. Then it's necessary to have the AND operator when passing an address. Well, this is address of. So both. So let's make another function. Let's make it here. Void.y short star n. So if we go y and pass a, both of these are passing an address, but this address is the address of what A is pointing at, where this is the address of what? Of A. But you notice that the prototypes have to be different because remember the ampersand adds a star to the type because a star has to point at a short star or holds the address of a short star. So the address of a short star needs a star star. Your question's kind of confusing, but the last bit I don't understand what you're on about. But yeah. two pointers can have the same address in this. Two pointers can have the same address in different functions. Do you mean the address of the pointers or what they hold? If you mean the address of the pointers, so if I was here and I had B and had int star C, no, they won't ever have the same address. Yeah, these won't have different addresses. I mean, these all have different addresses. But they'll never see each other, so it doesn't matter. Write a bit of code and show me what you mean. Because I don't know what you're trying to say. All right. Is there any other questions? Or are you writing the code? All right, I'll give you a minute. I'm going to have a quick break. If there's any other questions, if there's no other questions when I get back, then we might finish off. I'm not sure. Write out the code. Would you? Oh, I see what you're asking. Well, I'll have a discussion about it when I get back. All right, I'm back. So the question is, can I pass the address of a pointer to a function without using int star star? The answer is yes, but you have to use void pointers, which I don't really want to introduce to you at this stage, just because they're difficult to use. So given what you know so far, the answer would be no. The answer is technically yes, but given what you have in your toolbox, the answer is no. So the reason being is pretty simple. If I have int main and I have int a, if I want to pass the address of this, then my function has to have an int star. And I can't call it a, let's call it func. Okay. It has to have a star here so that I can send the address of a, because this is a pointer to an int, or a thing that can hold the addresses of ints. So if I have an int star b, I can pass b to this function, that's fine, because it's holding the address of an int, because it's a pointer to an int. But if I want to actually pass the address of this pointer, then I need a double star, because this is a pointer to an int star. Okay, and if I have an int star star c, and I want to pass the address of this, then I need an int star star star. Okay, and that's the only way, other than using void pointers, to get the address in there. Okay, does that make sense? Cool. Is there any other questions? One other thing while you're still here, which I just want to quickly show you, just making it wow. So I'm going to have hash include standard.io.h, and I'm going to have int func int a int main plus plus And then inside here, I'm just going to go printf %d, and I'm going to call my func. Okay, so will this compile and run? Everyone's kind of gone anyway. And the count has gone up slightly. So why won't it compile? Yes, good point. Cool. So will it compile now? Yeah, cool. All right. So the other reason I really give this example is purely just to show that you don't need function prototypes. And in terms of professionalism and standards, really you should be using function prototypes. However, I have noticed that some math in this lecture notes doesn't use them, and so I just want to show you that it does work still. I don't really agree with demonstrating that way, but too bad. Yeah, so just be aware of that, because it might come up in the exam or something. But yeah, for your code, please use function prototypes. It's definitely more professional. All right, well, I think that's pretty good. Is there any other questions? Any other comments? Any other issues? Any problems? Anything at all? Are we done? We're pretty much done. I'm tired.
All right, we might finish up there. Thanks, guys, for coming. Good luck finishing off your assignments if it's not finished. And use the forum if you need. All right, thank you.